Hello everyone, welcome back to Maker Mike. This old soldering iron looks completely worn out. The handle feels loose, the inside no longer works, and most people would throw it away without thinking twice. But look closer. A broken tool still holds structure, solid parts, and another chance to be useful. Today, this is not a repair. This build turns it into a compact 12-volt welding tool using simple materials you can find at home. Remove the screws one by one. Open the housing slowly and keep every small part in place. Grab the inner core with pliers and pull it out. The heating element and old wires no longer help here, so remove everything inside and clear the shell completely. Keep the handle, the plastic core, and the metal front section. Now take a spark plug and a red wire. Slide the plastic core back into the handle, making sure it sits firmly in place. Then feed the wire through the center channel. Push it slowly and avoid damaging the insulation. This wire becomes the main positive path, so keep it clean and straight. Once it reaches the front, reinstall the metal tip and tighten the screw. The body now feels complete again, but its purpose has changed. Bring in a spark plug. Strip the end of the red wire and expose enough copper for a solid connection. Wrap the copper tightly onto the spark plug and secure it firmly. The spark plug plays an important role. It provides insulation, a strong metal core, and a compact shape that fits inside the tool. It also helps concentrate electrical energy into a smaller area, which increases heat at the contact point. Wrap electrical tape around the spark plug until it fits tightly into the front metal section. Push it in slowly and twist slightly until it locks in place. The tape keeps the spark plug centered and reduces movement. Attach a screw terminal connector to the top of the spark plug and tighten it securely. This connector acts as a junction point. It allows a firm connection without soldering and keeps the current flow stable. Next, take another wire and strip both ends. Twist the copper strands tightly to keep them secure. Then fasten one end firmly into the screw terminal connector so it holds steady. Power will enter through the red wire and move toward the tip. Every connection must stay tight and direct. A loose joint will create heat in the wrong place. A weak connection will reduce performance. Careful inspection at this stage prevents failure during testing. Connect the other side to the metal contact area near the spark plug. This completes the internal circuit path and prepares the tool for power flow. Return to the back end of the red wire. Strip the insulation and attach an alligator clip. Crimp it tightly so it holds firmly. This clip will connect to the positive terminal of a 12-volt battery. The setup remains simple and flexible. You can connect and disconnect power quickly without modifying the main structure. If you have a better idea or a different way to do this, write it down in the comments so the whole community can see it. Prepare the electrode using an old AA battery. Use pliers to open the battery and remove the carbon rod inside. Work slowly to keep the rod intact. Carbon is ideal here because it handles high temperature and conducts electricity without melting quickly. That makes it perfect for forming a stable arc. Place the carbon rod into a drill and spin it slowly. Use sandpaper to shape one end into a sharp point. A pointed tip concentrates the current and creates stronger heat at a smaller area. If the tip stays blunt, the energy spreads out and reduces efficiency. A clean, centered point gives better control during welding. Insert the carbon rod into the front connector and tighten it securely. Make sure it stays straight and aligned with the tool body. Use a lighter to heat the rod briefly and remove any moisture. A dry surface ensures a stable spark during the first test. This build shows how simple materials can create a useful tool. With careful assembly and controlled motion, a broken device turns into something practical and reliable. Bring a 12-volt battery onto the bench. Attach the red wire clip to the positive terminal. Take another wire with clips on both ends and connect one side to the negative terminal. Hold the free end in your hand. The system is ready for testing. Touch the carbon tip to the free negative clip. A bright spark appears instantly. Start the first test with 2 razor blades. Place them together and bring the carbon tip to the joint. Touch lightly and move in short, controlled motions. Do not stay too long in one spot. Too much heat will damage thin metal. Move gradually and build small connection points. The metal melts slightly and forms a bond. Let the blades cool and test the joint. Bend them gently. They stay connected. This shows the tool produces enough focused heat for light welding tasks. Move to a stronger test with 2 utility knife blades. These blades require more heat and control. Place them together and begin welding along the edge. Run a quick check. The battery provides enough power. The wires carry current without interruption. The spark plug and connector guide the flow correctly. The carbon rod focuses the energy. Each part works together as a complete system. Touch the tip, create the arc, and move in short pulses. Watch the metal glow and soften at the contact point. The molten metal begins to connect both surfaces. Continue along the seam slowly. Each small weld adds strength to the joint. Let the blades cool completely. Then test them again. Bend them with more force. The connection holds. This confirms the tool works beyond simple sparks and can handle real metal bonding. The tool activates and concentrates energy at the tip. This confirms that the circuit works correctly. The current flows smoothly through the system and creates the heat needed for welding. Take the final test to a practical repair. Use a stainless filter mesh with a broken handle. Take a piece of steel wire and cut it into small segments. Keep each piece short and even in size so they are easier to position and control during the welding process. Place small metal pieces over the damaged area. Hold the handle in position and begin welding. Touch the carbon tip to the metal pieces and guide the heat into the joint. The filler metal melts and fills the gap. Work carefully across the break. Build the connection step by step. Here is the final result. The old soldering iron now works as a compact 12-volt welding tool. It creates sparks, joins metal, and repairs everyday items. This kind of upgrade saves money and extends the life of old tools. If you enjoy projects like this, stay with the channel. More practical builds and simple upgrades are coming next.